Have you ever had that specific sinking feeling where you are staring at a textbook or a screen or, listening to a lecture and you can practically feel your brain rejecting the information?
Oh, yeah. The storage full notification just blinking in your mind.
Exactly. You're reading the same paragraph for like the fourth time. You're highlighting things until the whole page is just neon yellow. You feel like you're pouring water into a bucket, but the bucket is just, well, it's full of holes.
It's leaking out as fast as it goes in. It's so frustrating.
It is. And the usual response is just to pour faster, right? Read harder, cram more, stay up later.
But today, we're actually going to stop pouring. We're going to look at the bucket itself.
We are doing a deep dive into a really fascinating set of lecture notes. They're titled Concepts of Learning.
This is a bit meta for us, I think.
A little.
Usually we're diving into, history or tech trends or something. But this is a deep dive on learning.
And the context here is really important. These are notes from Class 2 of a computer science course, CS330, to be exact.
But, and this is the key thing, they aren't talking about Python or C++ yet.
Not at all.
No, and I love this approach. The professor is basically saying, before I teach you how to write code, I have to teach you how to run your own brain.
It's like an operating system upgrade.
Exactly. You can't run complex software, like a new programming language, if your OS is buggy and your RAM is full.
And that's our mission for this deep dive. We want to move you from being a passive recipient of information to being an active architect of your own knowledge.
Yeah, and we've got psychology, some neurology, and some pretty distinct math on how to make things stick.
Honestly, even if you aren't a student, if you're just trying to learn a new skill for work or a hobby, this is the manual for your brain that you probably never got.
So where do we start?
Let's pop the hood. The notes begin with something called the engine of learning. I kind of assumed this would be intelligence or IQ, but it's not. It's motivation.
Right. Which, I know, it sounds a bit like a poster you'd see in a guidance counselor's office.
A little bit, yeah.
But the notes break this down into two very distinct mechanisms, extrinsic and intrinsic.
Okay, so I think most of us get the basic difference. Extrinsic is the carrot and the stick, right?
It's externally driven. You learn the material because you want the A, you want the promotion, or more often, you want to avoid the shame of failing.
The notes say the teacher is pushing the student.
Yep. Versus intrinsic, which is the pull.
Okay.
Intrinsic motivation is when the learning solves a problem you actually care about. It's relevant to your life right now. It's fun. Or it just satisfies a deep curiosity.
And the research is pretty clear on which one is better.
Oh, it's crystal clear. Intrinsic is vastly more effective for long-term retention.
This leads into a concept in the slides called andragogy. I'm going to be honest, I had to look up how to say that.
It's a bit of a $5 wish for sure. It was popularized by researcher Malcolm Knowles.
Knowles, right?
And he basically said, look, pedagogy is the science of teaching kids. Andragogy is the science of teaching adults.
And they're not the same.
They are not the same thing at all. Think about elementary school. Kids will learn something just because an authority figure says this is on the test.
Sure.
But adults, we're a bit more stubborn. We need to know why.
We're problem-centered.
Exactly. We have all this life experience. If you can't show an adult how some new information applies to their job or a problem they're facing right now, their brain just filters it out. It's noise.
So if you're struggling to learn a new tool at work, maybe the problem isn't that it's too hard. Maybe you just haven't sold yourself on why it matters to you.
You haven't found the pull yet. But, and this is a huge but in the notes, even if you're motivated, you might not have the capacity.
This was my favorite part of the source material.
Mine too. The theory of margin.
Yes. McCluskey's theory of margin. I'd never seen this before, but it's a literal mathematical formula for why we burn out.
It is. And it's simple, but kind of brutal. The formula is margin equals 1 minus load divided by power.
Okay, let's break that down because I want everyone to really visualize this. What's load?
Load is everything that burns your fuel. It's the obvious stuff, your job, your commute, your classes, but it's also the invisible stuff.
Like financial stress?
Financial stress, an argument with your partner, health anxiety. It's all the energy drain.
And power.
Power is the input. It's your resources, your health, your support network, your skills, your savings.
So mathematically, if your load is heavier than your power, that fraction becomes greater than 1.
Right, and 1 minus a number bigger than 1
is negative.
You have negative margin, and the notes are very stark about what happens then. You enter a feedback loop of just self-maintenance. It's survival mode.
Meaning you literally cannot learn.
You can't. Your brain doesn't have the bandwidth to encode new information because all your RAM is just keeping the system from crashing.
Wow. That hits home. I think about times I've tried to learn a new skill during a crazy week at work, and I just felt stupid.
Right. You think, why can't I get this?
Yeah.
And we blame our intelligence. We say, I'm not smart enough. But the math says, no, you just didn't have the margin.
Yeah. There's a prompt in the slide here I think is really important.
It is. It asks you to consider right now, today, what elements make up your load and what makes up your power.
Because if you don't fix that ratio, you can't just brute force the learning.
You can't. You have to either reduce the load or increase the power. There's really no third option.
Okay, so let's say we have the margin. The tank is full. We're ready to go. We pull out of the driveway, and we immediately crash into a wall.
Right. The next section is all about barriers.
And these aren't external barriers. These are the ones inside our own heads, the ego.
Yeah, this got deep pretty fast. The notes talk about goal orientation. So you can have a mastery goal where you truly want to understand the material, or you can have a performance goal where you just want to look smart.
And prioritizing looking smart leads to some incredibly weird behaviors. The notes call it self-handicapping. This blew my mind.
It's a fascinating paradox, isn't it? Have you ever had a big exam and instead of studying, you stay up till 3 a.m. watching Netflix?
All the time. And then I hate myself for it. I always thought it was just laziness.
It's not laziness. It's actually a really sophisticated defense mechanism. It's about something called contingent self-worth.
Walk me through that. How does sabotaging myself protect my self-worth?
Well, think about it. If you study for a week, you give it 100%, you try your absolute hardest, and then you fail.
Ouch.
That's a direct attack on your competence. That says you simply aren't good enough. And that hurts.
Yeah, it cuts deep.
But what if you don't study? If you stay up all night and then fail?
Then I can say, well, of course I failed. I was tired. I didn't really try.
Exactly. It gives you an excuse. It protects your ego from that direct hit.
So we manufacture the failure on our own terms to avoid a failure based on ability.
Perfectly said. It preserves the illusion that I could have done it if I wanted to, but of course, it completely destroys your actual growth.
This feels like it's tied directly to the growth mindset stuff.
It is.
Yeah.
The notes reference Dweck and Duckworth here.
Yeah.
And there are 3 rules of mindsets.
Okay.
For the fixed mindset, the one that leads to all this self-handicapping, rule number 1 is look talented at all costs.
And rule number 2 is, what, don't work too hard?
Right. Because to a fixed mindset, effort is a bad sign. It means you aren't a natural.
Whereas the growth mindset sees effort as the whole point. It's the key.
Correct. And rule 3 is about setbacks. Fixed mindset says hide your mistakes. Growth mindset says confront them.
That's where imposter syndrome must live, right? And that fear of being found out.
Absolutely. There was one other barrier they mentioned that I think is really important to define too. Stereotype threat.
Yes.
It's a heavy one, but it's well documented. It's the anxiety that comes from feeling like you're at risk of confirming a negative stereotype about your group.
Like the idea that, say, older people can't learn technology.
Exactly. And if you go into a class believing that, your brain is actually using up cognitive energy fighting that anxiety.
So it creates a cognitive load. It goes right back to our margin formula.
Yes, it does. And it can become a self-fulfilling prophecy.
So half the battle is just wrestling these psychological gremlins before we even open the book.
It really is. The psychology has to come before the neurology.
Okay, let's shift gears then. We've cleared the emotional blockages. We have the margin. Now let's look at the actual machinery, the information pipeline.
This is the classic model. It tracks how a fact goes from out there to in here.
Sensory memory, attention, working memory, and finally encoding.
And right at the start, there's a bouncer at the door.
Attention.
The notes call it the front door to learning. And the quote is pretty blunt. If you don't pay attention to the information, it will not make it any further.
It seems obvious, pay attention, but then the notes attack something we all do constantly.
The multitasking myth.
Oh, this slide.
I love this slide. It basically says, you think you're good at multitasking, you're wrong.
I feel personally attacked. I feel very efficient answering emails during a Zoom call.
You feel efficient, but you aren't effective. The research shows that multitasking is really just rapid task switching.
And every time you switch, there's a cost.
There is a switch cost. You lose data, you lose momentum, you lose focus.
So the advice for learning this course or anything is pretty strict.
It is. Put the phone in another room, close the other tabs. You can't have a party in the doorway and expect the furniture to get moved into the house.
Okay, so if attention is the bouncer, what gets past the velvet rope?
The notes list the evolutionary triggers: motion, size, intensity. We are hardwired to notice a tiger jumping out of the bushes.
And novelty and incongruity, too, things that just don't fit.
Right. If you walk into your office and your desk is upside down, you will pay attention to it. And the last one is emotion.
Emotion is a super highway to memory.
It is. It's why you remember where you were during a national tragedy, but you can't remember lunch last Tuesday.
Okay, so the info gets through the front door. Now it's in working memory. The notes call this the boss of the brain.
This is where the conscious processing happens. It's where you solve the problem. But, and this is the critical design flaw, it is tiny.
Extremely limited.
We can only hold a few items at once.
And the notes bring up a classic study about chess players to explain how we get around this.
Simon and Chase, 1973. It's a cornerstone of cognitive psych. So they took chess grandmasters and total novices. They showed them a chessboard with a game in progress for just a few seconds.
And then asked them to recreate it.
Right. And the grandmasters were nearly perfect. They crushed it. The novices could only place 4 or 5 pieces.
So the obvious conclusion is grandmasters just have a better photographic memory.
That's what you'd think.
Yeah.
But then they ran a second test. They put the pieces on the board completely randomly. Impossible moves. Total chaos.
And what happened?
The grandmasters fell apart. They were no better than the novices.
Whoa. So what does that tell us?
It tells us the experts didn't have more memory. They had better schemas. When they looked at the real game, they weren't seeing 32 pieces. They were seeing the Sicilian defense. They were seeing patterns.
This is chunking.
That's chunking. Instead of remembering 1,000 little details, you group them into one big chunk labeled Chess Strategy A.
The notes have a great visual for this. If you ask me to memorize the letters P-I-Z-Z,
You'd lose it pretty quick. But if I say pizza for dinner, it takes 0 effort.
because I already have a schema for what pizza is.
Exactly. And this all connects to constructivism. The idea that knowledge is recursive. You build new floors on top of the old ones.
Which explains why starting a new subject is so painful. You have no hooks.
You have no hooks. You are the novice looking at the random chessboard. It's overwhelming until you build those first few schemas.
So we know how the machine works. Now let's get to the hacks, the practical hacks section.
And this starts with metacognition.
Thinking about thinking.
Simply thinking about thinking. Stepping back and asking, is the way I'm studying actually working? And the research shows most of us are terrible at this. We just reread our notes and hope.
Which brings us to my other favorite phrase from this whole deck, desirable difficulties.
Oh, this is so important. From Bjork in Bjork. It's the counterintuitive truth that if your study session feels easy, you probably aren't learning much.
Wait, break that down. We are wired to seek the path of least resistance. You're saying that's wrong.
For learning, yes. There's something called the fluency illusion. When you just reread a chapter, it feels smooth. You recognize the words. You think, oh yeah, I know this.
But you don't. You're just confusing familiarity with mastery.
Exactly. Real learning happens when you struggle to retrieve the information. It's the difference between looking at the answer key, which is easy, and forcing yourself to solve the problem, which is hard.
That struggle is what actually builds the memory.
That's what encodes it. You have to lean into the friction. And the notes offer a mnemonic for this, A-E-I-O-U.
Good acronym. Okay, A is for apply.
Don't just read the rule. Use it. Write a script. Compare it to current events.
E is for elaborate.
Explain it. Add detail. Connect it to what you already know. Ask why. Over and over.
I is for interpret.
Translate it into your own words.
Yeah.
If you can only repeat the textbook definition, you're just a parrot. You don't get it.
O is for organize.
Give it structure. Draw a diagram. Build that schema we talked about.
And U is for understand.
Which is what happens if you do the other 4.
The notes also contrast generating versus consuming.
This is so key. Creating is better than consuming. Drawing a diagram is better than just looking at one. Writing a summary is better than rereading one.
When you generate, you're driving the car, not just riding in the passenger seat.
And you never learn the route if you're just the passenger. You look up and have no idea how you got there.
Okay, since this is a deep dive on these specific class notes, we need to talk about the homework.
We do. The slide is titled Working Memory in Action, and it links to a YouTube video.
We'll make sure you know the link is in the source material, but the instruction isn't just watch this.
No. The task is to apply everything we just talked about. Take notes, analyze why this video was assigned, how does it relate to load and power and chunking.
And don't watch it while you're scrolling on your phone.
Please, respect the switch cost. Give it your full attention.
And there's that other self-reflection prompt from the theory of margin. I think this is critical for everyone.
I agree. The assignment is to actually calculate your margin. List out, what is my load? What is my power?
If the math doesn't work, you have to change the variables before you try to cram for that next exam.
You can't optimize your learning if your margin is negative. It's impossible.
I think that's a perfect place to wrap. We've gone from the psychology of wanting to learn, breaking down ego and mindset, to the physics of how we learn.
And we've learned that it's supposed to feel hard. That's the biggest takeaway for me. If you're struggling, it doesn't mean you're failing. It means you're actually engaging.
So here's our final thought for you to chew on today. We talked about desirable difficulties. If you are breezing through your work or your studies right now and you feel totally comfortable, are you actually getting better?
Or are you just coasting? Are you optimizing for comfort or are you optimizing for competence? Because you usually can't have both at the same time.
Something to think about. Thanks for diving deep with us.
Happy learning.